Hi everyone, welcome back to the Coding Interview Must Know series. Today, we're looking at a classic and surprisingly clever array problem, finding all the numbers that disappeared from an array. The problem is simple. You're given an array of length n, and every number is supposed to be in the range from 1 to n. But some numbers appear more than once, which means some other numbers are missing. Your job is to find all the numbers that never showed up. For example, in this array, 4, 3, 2, 7, 8, 2, 3, 1. The length is 8, so the valid numbers are 1 through 8. We can see that 5 and 6 never appear, so the answer is 5 and 6. The most straightforward solution is to use a set. You put all numbers from 1 to n into a set, and then remove every number you see in the array. Whatever is left in the set at the end is your list of missing numbers. This method is very easy to understand, but it uses O(n) extra space, and the time complexity is also O(n). So can we reduce the space complexity to O(1)? Yes, by using a smarter technique called the in-place index marking method. The key idea is that the numbers range from 1 to n, and the array length is also n. That means each number maps directly to an index, and we can take advantage of this by marking those indices inside the array to indicate which numbers have appeared. Here's how it works. We scan the array from left to right. Every time we read a number x, we mark the element at position x-1 as negative. That tells us that x has appeared. We subtract 1 because array indices start at 0 while the numbers start at 1. And we always take the absolute value of x first, because some numbers may have already been marked negative. If we don't take the absolute value, we might read the wrong index. Let's walk through the example. When we see 4, we mark index 3 as negative. When we see 3, we mark index 2 as negative. Then we see 2 and mark index 1. Next we see 7, mark index 6. Then 8, mark index 7. When we see 2 and 3 again, their positions are already negative, so we skip them. Finally, we see 1 and mark index 0. After this pass, every index with a negative value represents a number that appeared in the array, and every index that's still positive represents a missing number. Since indices start at 0, we add 1 to each of those positions to get the actual numbers. In this example, index 4 and index 5 are still positive, so the missing numbers are 5 and 6. This method runs in O(n) time because we make 2 passes over the array. And it uses O(1) extra space because all markings happen directly inside the input array with no additional storage.